Hello. Today we're going to take a look at calibrating the HDI Advance scanning systems. Before we start doing that process, I would like to take a little bit of time to talk to you about how this process works and the basic procedure that we'll be using to do this. For this setup, this calibration, we're going to need a calibration board. The board size is going to vary depending upon which scanning volume you're going to want to set up. Our scanning volume is set up by two different values. First off, we have the width of the lenses from the farthermost position that both of the lenses that we can use in the scanner can see. So the scanning system obviously scans in stereo because we're using two lenses. That means that the width of our scanning area is only going to be as wide as both of those lenses can see. So that will be narrower in the front of the scanning volume if we have our scanner here, and it's going to be wider in the back, so we make sort of a trapezoid shape. So that width is fixed. The depth, however, so the depth of field is going to be set by the user. That depth of field is set by where you move this calibration board inside of your scanning window. So if you move it closer forward, then it's going to be at a set forward position. If you move it further back, then your Z depth is going to be at a set further distance. Generally speaking, you don't want to go any more than the same length as the width of your field of view. You'll probably want to be a little bit less than that, as a matter of fact. The easiest way to know where the back and front of your Z depth or your depth of field should be is by the focus of your focusing pattern on the calibration board. Okay, so let's go ahead and start working on our calibration. So just to give you a few notes to be aware of, when you're using FlexScan 3.1, your software is going to look like this. When you're using FlexScan 3.2, you have just a few icons up top. Most importantly, new and remove. Whenever you want to create a new calibration, you must first remove your old calibration. So just a nice thing to keep note of for in 3.2. Alright, so we can go ahead and create our calibration. If you are using 3.1, you want to make sure that you have Duo selected. 3.2 will automatically run through that for you. So I'm going to overwrite this calibration. Once you've done that, we can go ahead and begin working on our calibration. So the first thing we're going to want to do is select each one of our cameras. That's done by simply grabbing them and selecting them. We also want to make sure that our projector is being shown. If not, we can come out to our screen, hit personalize, display, change display settings, and then identify your display. You'll also want to make sure extend these displays is set up, as well as making sure that both screens are on their recommended settings, especially this Optima XVGA. You want to make sure that that's on its recommended setting. Once that's done, you'll see what looks like a gear over here on the right hand side of the software. We can grab that gear, and then you'll notice it brings up our two cameras. So we can see there's my hand in one, there's my hand in the other. So let's set this value to 16 milliseconds, which it should be at by default, and then also the pattern we want to change to focusing. So it's a little difficult to see on the camera, but I'll go ahead and try and show that a little better. We have our focusing pattern. This is very important to the overall scanning project because we will want to make sure that our scanning system is properly in focus to get started, and then we'll build our calibration around that focus. We'll go ahead and get started by first focusing the projector, which is done in two ways. When you're using a larger scanner setup, so if you're using anything that's on the medium or the large bolt hole locations on the bridge, we'll want to turn this zoom ring all the way to the right, so all the way towards me. Then up under the hood, and it's a little tricky to get to, we have our focusing ring, where if we simply lift up on the hood, we can bring that properly into focus. Okay. So once everything's been put into focus, then we can go ahead and focus our lenses. So one important thing that I want to cover, and we'll readjust the focus just a little bit, but that's that we want the focus center to be in the position at which the two lenses intersect. So this is actually really easy to find, and we can do so simply by finding the point at which the two windows here look identical. So any other time they'll look mirrored. They'll look like a mirror opposite of each other, but there's a point at which that mirror turns, that mirror reverses, and at that position where they're both identical, that's where we want to set our focal center to. So we'll just slightly readjust for that, and that is what's going to actually be the middle of our depth of field. So we'll go up some and we'll go back some. Now before doing anything else, we're going to go ahead and focus our lenses. So my lenses were already focused, but most likely when you get your system, your lenses are going to look something like this, where they're going to be way overexposed and way out of focus. So the way to set that up is you want to keep your fingers out of the projector and come up to where it just starts to turn red, and then slide back down just a touch with your iris ring. So again, we're going to find where it's red and then come back down to where it just comes out of the red, and then we're good to go with that. The next thing we need to do is focus the two lenses, which is going to be manual. We're just going to manually focus these by eyeballing it, and it doesn't have to be perfect. You want it fairly focused, but you don't want to spend hours on it by any means. Once you see the point at which it comes into focus and comes out, and you know you're in the correct spot, then we're good to go. So the next thing that we're going to do is we're going to go ahead and start taking some images. So we're going to begin our calibration procedure. To do this, first I just kind of want to identify where the front and back of my focal depth is. So, and it's not something that you're going to be able to very easily see on camera, but there's a point at which the projector's focus pattern starts to go out of focus. And where that's at, I'm just going to take take this tape and put a line right there. So that is going to be our very front portion of the scanning window. Then also, we're going to find where it starts to go out of focus in the back, and that's going to be the very back of our scanning window. All right. Then we want to begin taking images all inside of this scanning window. But before we finish with that, let's go ahead and, just for fun, define where the other two sides are. So where this full box will be set up. And we can do that simply by finding when these two images here on our screen, the first one will start to go out of view. Okay, so when we find this position where it starts to go out of view, which we can see in the bottom window on the right hand corner of the screen, we're going to go ahead and just mark that with our piece of tape. Okay, so that just gives us a nice little visual. This is really your beginner basics, just to get you acquainted with the calibrating procedure. So again, we're going to find the point at which the calibration board comes out of view. This time it's going to be on the top camera. Once we find that, we'll just mark it with a piece of tape. And now it's pretty much as simple as filling in this area. So to fill in this area, what we want to do is, first we're going to want to take as many images as we can throughout this bottom section. So what I mean by that is we're going to tilt our camera up to where we're just capturing data in the bottommost portion of both views. So we'll capture an image there. We'll move over and capture another image. And then we'll move over and capture one more image on that boundary. Then we can move forward. And when we move forward, we're going to want to tilt this down some and continue taking these images. Now, one thing to note, and in fact, I'll just do it in the opposite direction so you can see a little bit better, is I'm taking these different images at a slight angle. I'd say we're probably at around a 20-degree angle right now, relative to the front face of the projector. The reason we do that is it helps to fill in the gaps, so to speak. If we don't take these images at an angle, we'll tend to get data that's really just spaced out, and it's not going to result in the best calibration possible. So now we're going to move forward a little bit more, and we're going to tilt the camera down once again. So now at this forward position, one thing you're going to notice is the line that we drew is most likely going to be insufficient as far as a boundary for the very front. If we came all the way up here, you can see that the top calibration board is all the way out, or almost halfway out of view. If we were to capture an image right there, we will see that we'll most likely get an error, which we did, because one is halfway out and the other one is partially out as well, so there's no way for the camera to capture data. So when you come in and do your calibration, one of the important things to note is that both cameras have the calibration board entirely within their field of view. Now when we get all the way up front, there's a chance that it's going to be slightly overexposed just because there's more light the closer you get. So you can turn your brightness down slightly to bring that exposure down and get a better image all the way up front. So we're going to fill in the front. Okay, once we've gathered the same data all the way up front, now we finish this bottom layer. So we're going to want to come up 2 more layers. So we'll have a middle section and a top section. So we'll start all the way up at the front and then move our scanner down until the calibration board is about in the middle of the 2 view windows here and here. So we can continue taking our data. Using our bounding box, which we've now modified to be more of a trapezoid as our guide. We'll also start taking these at an angle, which we should always try to do when we can, because it will result in a much better calibration. Okay, once we've done that, we're going to move all the way up, which we can see the back is already at that top position. If we wanted to, we could have moved this up just slightly and taken a few images to capture some data at the very back. This will allow us just to calibrate that a little bit more. So once we've done that, we can go ahead and tilt the scanner down a little bit more to line up with the top of both view windows, capture a few images, and then we'll move all the way to the front. Now, another important thing to note, we move that down, is when you're taking this data, this is just a very quick and simple calibration. This will get you a nice, clean amount of data. It is not the very best calibration that you could possibly get, but it is a extremely sufficient calibration for the majority of scanning needs and to get you up and running. So we'll go ahead and press calibrate and let it calibrate. To further refine your calibration, you can do the entire process that we just covered, but instead of doing it solely at this angle, repeat the whole entire process with this calibration board at the opposite angle. That's going to give you a more refined calibration, and it'll take you from 25 to 30 scans all the way up to around 60, 50 to 60 scans. But it's well worth it when accuracy is a very large requirement. So once we've done this, we can see that we've gotten a good calibration. Okay, so now we've gone ahead and done our calibration, and we can see the results of that calibration. So once we press calibrate, we'll get this little window that'll pop up after it does its processing, giving us our calibration space coverage, our standard deviation, and our average rejection error. So the calibration space coverage, the recommended coverage is above 65% on the software. I generally recommend above 80 or 85. Anywhere 85 and up is a very nice calibration for the coverage. Then we will also want to keep an eye on our standard deviation. So our standard deviation for this setup is plus or minus 19.3 microns. Now, if you're using a smaller setup, that image or that number is going to be larger. If you use a smaller setup, it's going to be smaller, and if you use a larger setup, it's going to be larger. It depends entirely upon what size lenses you're using, where they are in position to the camera, and so forth. So once we've done that, we can begin scanning. Another just quick thing to note that I didn't mention is when you're not using the standard 15mm calibration board, say you're using a 3mm, a 5mm, or even a 25mm calibration board, you're going to want to change this calibration board square size. That is very important to ensure that you get the proper accuracy and the correct resolution on, or the correct sizing on your images. That number does define the actual size of the scan, so it is referencing back to those individual artifacts. If that number is for some reason wrong, then your data will also be wrong. So just another quick note. So now we'll go ahead and finish this off by taking a quick scan. So we can come over here in scanning, press scan, let it generate the images, and now we can see here on the screen in just a moment the portion of the skull that we're working with. And I can move it back a little bit, maybe bring it further back into the focal range, take another scan. So we can see that our scanner is properly up and running. We're able to come in and create data, and we can begin doing our work. So thank you for taking a look at this video, and if you have any questions, feel free to give us a call or check out some of our other videos and resources on running the HDI scanning systems.